to the next point. We should ensure that whatever we see is clear.
That means work is being done. We can see that it is in opposite direction.
Good day, my learners, listeners, and viewers at home. Welcome to yet another opportunity on the e-learning platform organized by Kaduna State Ministry of Education. Today, we are going to discuss a topic which is known as limits and feats on the subject metal work. Before I proceed, my name remains Nathaniel James Yayok, your metalwork teacher. On considering limits and feats, we are going to go through the following outlines. Number one, we have the definitions of terms. There are terms that we are going to acquaint ourselves with, like limits, feats, which includes clearance, transition, and interference. Then we'll now see allowance, tolerance, whole basis system, sharp basis system, limit gauges, and then we summarize and take assignment. So come with me. By way of the introduction, in engineering craft practice, especially in metalwork, there is what we call interchangeability and precision. Now, these two words are key in production. Interchangeability means having a product or a finished work in Nigeria, taking it to United States or the UK, and it can fit or balance to a particular component over there. That is interchangeability. You take it to any country, anywhere, it fits in exactly. And then precision is the accuracy, the precise dimension and measurement that you need on a particular work piece or a product. Now, in mechanical engineering practice, limits and feats are a set of rules regarding the dimensions and the tolerance of mating machine parts if they are to achieve the desired ease of assembly. Now, by this introduction, anyhow you produce a part and take it to anywhere for assembly. Now you have to consider this topic, which is limits and feats. Now, if the part or the workpiece that you produce is within a certain dimension, that is the limit at which that particular product is produced. And then when you take it to fit it into another component, either a hole or a shaft, it meets and then give you exact dimension that is required. Now let's take some definitions on the terms that we have highlighted on our outline. The first one is limits. Now we'll try to see what is limits. There are two extreme sizes for a given dimension. They represent the largest permissible size for a hole or shaft and the smallest. Every hole has limit dimension to which must be bore. Now, if we are talking about limits, we have the upper and the lower, or the lowest and the highest. Now, every hole or shaft have the same limit. For example, you may be asked to bore a hole of up to 30.015 millimeter and not below 30.00 millimeter. There are two different things there. The difference is one is carrying 0.015 and one is 0.00 millimeter. So in this example, 30.015 millimeter is the largest permissible. Is the largest permissible size, and then the 30.00 millimeter is, of course, the smallest. So these are two different dimensions. But on each hole or on each shaft, they have the largest and the smallest permissible size. Now let's take feet. We say feet refer to a system of mating shaft and hole. There are three basic types of feet. Namely, we have three basic types of feet that are namely, one, we have the clearance feet, we have the transition feet, and the third one is the interference feet. Now, let me further explain this feet. The coming together of the shaft into a hole is the feet we are talking about here. Now, clearance as a feet is when the size of the hole is greater than that of the shaft. It's said to be a clearance feet. Therefore, because we are talking about assembling, putting parts together, coupling parts together, either on the automobile, in the factory, in the production plant, and anywhere, we are talking about fitting. Okay? Something going into another component. That is referred to as fitting. So here, in assembling in a clearance feet, the shaft can be pushed into the hole easily. That is one of the characteristics of any clearance feet. There is ease of assembly. No force is required. When you put the component part together, they fit into each other, and that we refer to as clearance feet. Then we have the second one as transition feet. Now, on the transition feet, when the size of the hole and the shaft are the same, then we said to have a transition feet. For instance, the size of the hole is 30 millimeter diameter. The size of the shaft is 30 millimeter diameter. Now, what happens here is they have the same size. Now, assembling in this kind of feet requires a little force, just a little force. Like the biro I have with me. Now, I can take an example that this is a shaft and the cover as the hole. Now, on this, when you push the biro into the cover, now you have what we call fit. The biro fit into the cover, meaning the shaft fit into the hole. Now, with a little force, that means the diameter of the shaft as well as the diameter of the hole are the same. So assembling in this situation requires just a little force to fit in together. So that is on the transition feet. Now the last one, which is the interference feet. When an interference feet, the lower limit of the shaft is greater than the upper limit of the hole. Now, a considerable force is required for this kind of assembly. Of course, this could be seen in the automobile where you have the crankshaft being connected on with the connecting rod. That kind of feet that connects the crankshaft with the connecting rod is an interference feet because the upper limit of the shaft is greater than that of the hole. So a considerable force is required for such assembly. And we can go on and on and on to have examples of interference feet. Sometimes you need a hammer, sometimes you need press to press the component part together to fit into the part in which is designed to accommodate. Now the next term I want us to know or get acquainted to in terms of limit and fit is allowance. Allowance. We say allowance is the difference between the upper limits of the hole and the upper limit of the mating shaft. Now, all these terminologies regarding limit and feed goes back to mating two component parts together, like I said earlier on. So, if the upper limit of the hole and the lower limit of the shaft are greater, then allowance come to play. You give an allowance and the two mating part fixed together. That is what we refer to as allowance. Then the last term I want us to consider is tolerance. We give tolerance. Sometimes on the question paper or during your practical period, a teacher will give you an assignment, a practical assignment, and on the instructions, he will write plus or minus 0.2 millimeter tolerance. You are to consider a minimum tolerance of 0.2. Now, like I said earlier on, when we have 30.015 millimeter as the highest permissible size, and then we have 30.00 millimeter as the lowest, now there are two different things. So when you are considering tolerance, you must give that tolerance both the upper and the lower limit of the hole or shaft so that assembling will take place effectively. And then in the question paper, when you go below that tolerance that is given, then you have succeeded in not to answer the question correctly. But if you go based on the 0. Is it 5, is it 2, is it 3 that is given, then you are exactly at the tolerance that you are asked to give. Now, I want us to look at the whole basis system. The hole, because we are talking about hole and shaft. So the diagram on our screen shows exactly what the 3 feet are talking about. I mean, the clearance feet, the transition feet, and as well as the interference feet. They are all demonstrated on the sketch on the screen. Now, every size of hole has the same limit with feet obtained by applying different limits to the shaft. Now, on my left, on the diagram, we have the diagram arrow and letters being attached to each arrow. Now, the first arrow by my left is A, and we say A is the minimum hole size. And then the next one is B. The B is the maximum hole size. That means on the hole alone, we have the largest and the smallest, or the biggest and the smallest. So then when you move further, you will see arrow C. That arrow C is on the shaft. Now on the shaft, we say C is the maximum shaft size. That is the maximum shaft size. Then the D still on the shaft represent the C is the minimum, while the D is the maximum shaft size. So it has the highest and the lowest too. Now, when you go up a bit, you will see 2 arrows carrying E and F. So the E now is the shaft tolerance, and we talk about tolerance. Okay, is that allowance that is given between the shaft and the hole. And so the last one, F, is the positive tolerance. Now we talk about tolerance, we talk about allowance and fit earlier on. So the F is the positive. Now when we say positive here, is that situation where the allowance is enough or the clearance is enough to allow the shaft to pass through the hole. That makes that type of feed a clearance feed because no force is required to carry out this assembly. Now, when you move to the next diagram, which is also showing us a letter G, and G on the sketch, you can see the arrow showing you G, which is the hole tolerance. It's just about the tolerance. Now, the lines that the arrow are touching are the tolerance of the hole. Now, when you look at, when I explained the transition feed, I said they are the same. When you look at the line on the shaft and the line on the hole on the diagram, they meet each other at a point, this very particular point. So assembling in this kind of feed require a little force. A slight force is required because of the tolerance given. Now the last one, which is the interference. When you look at the interference on the sketch, is a little bit different from the first one and the second one, which is the clearance and the transition. Now, I explained to you that on the interference, a reasonable or considerable force is required to carry out this assembly. So when you look at on the sketch, you will see that the hole is less than the shaft. The shaft entered into the hole. You looking at the arrow, and a great amount of force is required for assembly. Then the next one is the shaft basis system. Now on the shaft basis system, we say the limit provided on the shaft should be the same for a given size by varying size of the hole. Different feed will be obtained. Now on the diagram, they are just the same in terms of sketch by the clearance, the transition, and the interference. But this one is talking about the shaft basic system. But the first one is talking about the whole basic system. Let's see some of the limit gauges. Of course, we have what we refer to as limit gauges. Now, limit gauges, by way of definition, are used as inspection tools. They provide a simple alternative to a complex measuring tools. They have double ends. One represents the upper limit and the other one represents the lower limit. Just like I have been saying from the beginning, we are talking about the hole and the shaft, the upper and the lower. One represents the upper limit and the other one represents the lower limit. Now, let's see some of the examples of limit gauges. We have one, the plug gauge. We have the gap gauge. We have the snap gauge. We have the ring gauge. We have the depth gauge. We have the thickness or filler gauge. We have the radius fillet gauge. And we have the dial gauge. All these gauges that I have mentioned, you will see the sketch on the screen. Now, these gauges, all of them carries what we call the go and the not go. If you look at the plug gauge, it has by the left a go, and then by the right a not go. When you look at the gap gauge, at the top we have the go, and at the bottom we have the not go. Now, these two ends, they have this go and not go because it has been precise. The measurement, the size of the go and the not go are not the same. So when assembling, if the component part fit into the go, then we'll say it has the same limit with the material. That is, interchangeability can take place. Now, it is also the same with the snap gauge, the ring gauge, the depth gauge, the thickness or filler gauge, the radius or dial gauges are all their standard measurement without a scale. Some of them don't have a scale that will show you, but they are standardized. Once you pick a particular gauge on the workpiece or the material you are checking, because we said earlier on that these limit gauges are inspection tools. They are used for inspections to check whether the material or the workpiece or the tool is at the standard, is at its limit. Now, all this will give you, but let's see only two, like the plug gauge. Let's see what it does, and then the gap gauge. Now, we say the plug gauge are used to inspect holes that have been drilled or bored. The gauge has go and not go end, which are hardened and ground. If the go end enters the hole, then it is above the low limit or the lower limit. Now, if the not go and goes into it, then the hole is below the limit and therefore will be accepted. So once it is accepted, then we'll say it is the standard limit that is approved for that company. Then the gap gauge are used to check the size of prepared plates, which is made from a gauge plate. The gap gauge also have two sides, the go and the not go slot, to assist in the inspection. Now, when we say go and not go, and we are talking about shaft and then plates, while the plug gauge is trying to make sure that a hole is standard at the limit. Now, for instance, we all know what is drilling. Drilling operation is creating a hole, and each hole has a limit. It has a standard. All the drills are made in those standard. So the plug gauge is inserted into it to check whether the hole is at the limit. Now, on fitting work on the table, we have plates of different sizes, of different thickness. So the gap gauge is used to check the thickness of that plate, whether it is at the right limit or at the proper limit or at the precision limit. We have come to the end of our lesson today. But before we go, let's just summarize what we have talked about by seeing what engineering fit is all about. Now, engineering fits is referred to the clearance between two meeting parts. Two meeting parts. The choice of an engineering fit determines whether the two parts can move relative to each other in case of a clearance fit, or act as a whole in case of a tight interference fit. That is all about fits and limits in engineering. Before we go, my students and listeners at home, I would like to leave you with the following assignment. Question 1A. Why do we use limits and fits in engineering? It's a very important question. We need to know why we use limits and fits in engineering. B. 1B says, what is allowance and tolerance? What is allowance and tolerance? Then number 2A, define limit gauges. What are limit gauges? B, give 2 examples of limit gauges. You are to give only 2 examples. We have given so many of limit gauges, so give me only 2. Then number 3, state 3 main types of fits and explain how each can be obtained. We've mentioned about 3 limits. Now, you are expected to state 3 and explain how the clearance feed can be obtained, the interference feed, and the transition feed can be obtained. Thank you, my students at home, for listening. My name still remains Nathaniel James Yayok, your metalwork teacher. You can reach me for any further inquiry or to answer the questions given on my WhatsApp number on 081 30 86 32 82. I repeat the number again, 081 30 86 32 82. Please stay safe, keep learning. Corona is still real. Let's observe all the safety measures put in place by the government. Thank you till we meet in our next class.